following graph that we have here shows us the growth of a fox population in a wildlife preserve. And on this graph, we have that the time in years is given to us along the horizontal x-axis, and that the fox population is given to us on the y-axis, the vertical axis. This here then tells us that time is our independent variable, and the number of foxes, that's the dependent variable with this. And now we're going to work through some problems asking us different questions about this graph. The first one is asking us to estimate the year in which there will be 400 foxes. So that means on my graph, I'm going to take a look at 400 along the y-axis. And now I'm going to continue along there and see where that is approximately crossing on the graph. I get to about this point on my curve, and now I can go down to figure out approximately what year that is. And we have it at that one dash down there. And if I look closely, it looks like my dashes have to be going up by 2s in order for this to get to 10. So that being at the fourth dash on the x-axis tells me that that would be in approximately year 8. Next, I want to know how many foxes will there be in 6 years. So if we do a little labeling on the x-axis there, we can see where 6 is at. So now I want to take that and go up to my curve and see where that is approximately crossing. And we can see that's halfway between 300 and 400. So we could say there would be around 350 foxes. The next one asks us to write a sentence explaining the ordered pair 2, 250. And with our ordered pairs, we remember they are input, output, or independent, dependent. So the 2 is representing years, our independent variable, while the 250 is representing foxes. So if we want to write a sentence to explain this, we could say, in 2 years, there will be 250 foxes. The next thing we're going to go over here is the average rate of change of a function. And what this is our change in the dependent variable, change in our y variable, divided by the change in the independent variable, the change in the x's. And we need to be careful with this change to make sure we're following or staying consistent with these two. So just to make sure that we're consistent, we're going to have that the change in the dependent variable is our value after change minus the value before change. And then similarly with the independent variable, it's going to be our value after change minus the value before the change. So now we want to find our average rate of change in the fox population in our example of above between years 2 and 14. We already have our ordered pair from year 2. That was 2, 250. But now we also need our ordered pair from year 14. So let's go up above and figure out how many foxes there were in year 14. So we have 14 is this one dash here. So we can go up to evaluate approximately how many foxes there are. And we can see there is about 450 foxes in year 14. So our ordered pair for that would be 14, comma 450. So now our average rate of change, we can calculate this by taking our value after change for the dependent, which is 450, and subtracting the value before the change, which that is the 250. And then we need to divide this by our change in the independent variable, our years. So we're going to have 14 minus 2. So this gives us 200 over 12, which then if we evaluate what that is, you should get, it's about 16.666, keeps going on, so I'm just going to round this to 67. With our average rate of change though, these are rates, we like to have units with these. So let's think about what the 200 is with this. Well, that 200 came from the 450 minus 250, and those were representing foxes. While the 12, well, this came from taking 14 minus 2, and the 14 and the 2 were representing years. So we had 200 foxes over 12 years to tell us our unit for the 16.67 is foxes per year. And now that also helps to explain what this average rate of change means in a sentence. We could say that there is an average increase of about 17 foxes each year at the wildlife preserve. And it's increased because our rate of change was positive. If a rate of change is negative, then that's implying that it's decreasing.